Good afternoon from Washington, D.C. This is Ed Salzberg. I'm the Executive Director of the Security and Sustainability Forum, and I welcome you to what is about our 350th webinar, many of those with Arizona State University since we started doing webinars in 2009. If you don't know SSF, please go up to the website. A ton of free climate, energy, and environmental education on the website. We make it all free for in largely because of the work that ASU supports, so I thank them for that. I'm pleased to be working with Bill Brandt on what we think is, with Bill Brandt again as the moderator. He's the Director of Strategic Integration at Lightworks at ASU, on what we think is a really impactful and important webinar on the next climate frontier, industrial decarbonization. We do have solutions for the other sectors, energy, transportation, agriculture, that are moving forward. Industrial decarbonization is a different story. Over 900 people registered for the event, and thank you for doing that. We know you have lots of choices for where to go, and we're just humbled that you chose to spend time with us today. Bill is going to introduce the speakers, but I want to point you to the survey at the end of the session. Please take that. It'll take you a few minutes. It gives us some guidance on where to go from here. And also, we have a special question about a post-webinar workshop that we're going to be doing on this topic that you can opt into if you're interested in furthering the discussion. Add your questions to the GoToWebinar window. We'll get to as many of them as we can, and the video will be ready later today. You'll get an automatic email with that. We're going to be holding a post-webinar session on industrial technologies, industrial decarbonization technologies. If you want to get more involved, if you have something to contribute, this is not really about education, it's about contribution and participating to solving problems on the road to a clean economy. There is a question in the exit survey about that, and please click that button and we'll invite you to that session. Bill is going to provide a little context, and then he'll introduce the panelists one at a time. They'll each make about a 5-minute set of opening remarks. Then we'll move into a discussion that Bill will moderate, and we'll go to audience questions, maybe intersperse them. At the end, the panelists will offer up a few closing remarks, and then I'll close the session. And with that, let me turn this over to Bill, who will kick us off.
Thank you, Ed, and hello, everyone. And thank you for joining us today. As we come together in this critical webinar, we're not just participants, we're collaborators on a vital mission towards a sustainable future. It's heartening to see that we found cost-effective solutions to address 70% of global emissions, particularly in sectors like energy, buildings, and transportation. This progress is a beacon of what's possible when we unite in purpose and action. Yet, our work is far from done. The heavy industry sector, a significant contributor to the remaining emissions, stands before us as a challenge. But in this challenge, I see an unprecedented opportunity for innovation, for transformative collaboration, and for leadership that transcends traditional boundaries. Today, we've convened a diverse group of thought leaders from industry, finance, academics, and policy under the auspices of ASU Lightworks and the DOE-funded Electrified Process for Industry Without Carbon, EPICS. Our goal is to forge a path for not only what secures manufacturing competitiveness, but also aligns with our deepest environmental commitments. So let's engage with one another today, not just as colleagues, but as co-creators of a future we all can believe in. Let's ensure that our strategies for a sustainable future are robust and resilient and reflective of a diverse world that we live in. Let's remember this is not just about the world we leave behind for future generations, but it's about the world that we're going to build together today. So I encourage you to think about your role and what you can do in this vital effort. So whether you're a policymaker, an innovator, or an industry leader, you have a part to play in reshaping the sustainable future for all. Ed, thank you for outlining how this conversation is going to go, where I will make introductions of each one of the speakers who will give an opening statement, and then it'll turn into a conversation. And we invite you, the audience, to put your comments into the chat, where Ed and I will curate them and then use those questions to help enhance, enlighten, and power up the conversation. And then finally, we will conclude with a short statement from each one of our panelists about the observations that they see that are important to them. So we'll start out the discussion with Sridhar Sitharaman. Sridhar is the CEO of the EPIC-C, Electrified Process for Industry Without Carbon. It's DOE's 7th Clean Energy Manufacturing Innovation Institute. Previously, Sridhar was Vice Dean for Research at ASU, Ira School of Engineering, served as a DOE as a Senior Technology Advisor at EERE, and at Carnegie Mellon as the POSCO Chair of Steelmaking with a joint appointment at Nettle. Sridhar.
Thanks. Thank you, Bill. And thanks everyone for joining this session. And I want to contextualize a little bit about where industrial decarbonization stands. So if you use the maths based on what Bill just said, industrial emissions accounts for nearly 30% of greenhouse gas emissions in the US, and worldwide it's not too far behind either. Commonly, the emissions that industry emits is divided into what's known as Scope 1, which are usually the emissions controlled directly by the factory or facility. These, to a large extent, can be divided into two buckets. It's either just combustion used for process heating, or in some cases, it's processes that inherently produce CO2 chemically. This could be, for example, carbothermic reduction of iron ore or calcination for producing cement. Now, coupling to that, you have Scope 2, which includes the direct supply, such as raw materials, or more importantly, perhaps power used by the factories, the cleanliness level of that power. And so these are the buckets in which industry emits carbon or greenhouse gases. Now, the Department of Energy has identified for us a roadmap of what key levers or pathways we have for reducing that decarbonization and achieving net zero. The different levers include carbon capture, sequestration, and utilization, improving efficiency in plants. If you improve efficiency, there's less energy use and less amount of carbon burned as well. Replacing carbon-based fuels with low carbon fuels or reductants in some cases with other things that could be, for example, hydrogen. Or finally, electrification, where you basically replace electrons as a feedstock instead of fossil fuel. So EPIC, and Bill already introduced EPIC, so I won't go through that. EPIC is addressing process heat. So essentially, process heat in total accounts for about 10% of global greenhouse gas emissions. And this is just for heating various types of raw materials up in industrial processes. That can range all the way from, industrial food processing for baking and frying or pasteurizing as, slightly over 100 or 200 degrees centigrade, all the way to smelting of iron and steel at 1600 or above centigrade. So you go through a wide range of heat duties and temperatures, and EPIC is looking to find a solution to replace all of this combustion heating with electric heating. So we address all the major emitting industries, wherein chemicals and petrochemicals are the largest emitters, and my colleague Michael will expand on that a bit. This is followed by iron and steel, food and beverage, paper and pulp, and cement. So the way that EPIC operates, like all the other manufacturing institutes, we are a public-private partnership which seeks to develop and de-risk scalable and cost-effective solutions, in our case for implementing electric heating. The type of solutions or the type of problems that we look at is basically you need to provide the power needed for these factories. It's not as easy as turning off cars or homes. So synchronization and operation with renewable power is a major part of what EPIC might be looking at. Integration of electric heating technologies into manufacturing systems, i.e. you want to mess as little as possible with factories as they operate right now. And you want to be able to operate with the same types of raw materials, at least the same quality of products, and be able to install things, retrofit things without messing too much in the process, right? So integration of electric heat technologies within production lines. Finally, whatever technologies come out of EPIC, they can only be deployed as far as you have workforce that knows how to deploy it, right? So you need workforce trained in high voltage systems, power electronics, power systems that can integrate those into manufacturing lines. So that's a significant part of what EPIC will be looking at too. And finally, analysis and forecasting. So there'll be various technologies being developed, and in the end of the day, we want to be able to compare them cost effectively with one another, but also competing technologies such as hydrogen combustion or biofuels or even carbon capture and sequestration. So in the end of the day, EPICS as such is not a single company problem. It's something where we have to engage the entire supply chain, because solutions are not limited to a factory alone. Because if a factory is using electric power or increased electric power, that power needs to be available when they need it. It needs to be green. The incoming raw materials need to be processable. So for example, if you're looking at a steel plant, you need to be operated with the same type of minerals that you have been previously. The products that you're producing have to be acceptable and processable upstream, just like they were previously. So basically, also the supply chain for the equipment you're trying to install have to exist. For example, if you're implementing a certain type of heating technology, be it plasma, microwave, whatever it may be, that has to exist at scale to be able to actually make a difference, right? And as I mentioned, workers have to be trained. And finally, and very importantly, communities around factories have to benefit from the output of what happens from these technological deployments as well. The whole industrial decarbonization is part of energy transition. And past energy transitions haven't always been equitable. Sort of located a lot of chemical and petrochemical plants around redlining areas that have borne the brunt of pollutions, but not necessarily reap the benefit of the profits. We want to make this transition more equitable. So communities around critical manufacturing plants would also need to be benefiting from not just the loss of less pollution, but also from the high value jobs being created. So as a summary, EPIC seeks to bring together manufacturers, technology developers, utilities, educators, union, and communities to together work out solutions that are cost effective, equitable, and sustainable for long terms to come by creating this unique ecosystem. So with that, I think I should pass the baton back to you, Bill.
Thanks, Sridhar. Thanks, Sridhar. Appreciate those opening comments. Our next speaker is Vijay Swarup. Vijay is the Senior Director of Climate Strategy and Technology at ExxonMobil Corporation. He currently oversees the corporation's strategy to reduce greenhouse gas emissions and address climate change. This includes climate policy and advocacy initiatives, along with the interplay between policy and the advancement and implementation of technology. Vijay has been with ExxonMobil for over 30 years and has held a variety of leadership roles in both business and technology functions. Vijay, thank you.
Well, Bill, thank you so much for the invitation, and it really is an honor to be here. And the fact that we can do this by webcast is a testimony to energy. The fact that we have the energy to be able to do this. And so, Sridhar, those were great opening comments. Wow. I mean, they were extremely comprehensive. And if I was to use 2 words to describe what you talked about, it's integration and scale. And you mentioned scale a number of times. I want to come back to integration. But what I'd like to do is let's just elevate this a little bit for just a minute. Let's just make sure we're all aligned on what the challenge here is. The challenge is people need energy. Energy is fundamental to quality of life. People may or may not recognize that, but everything around you is a derivative of energy. And we have to continue to provide that energy because we don't want energy to be disrupted. Those of us that have experienced disruptions in energy know that it's not what you want. It's not anything that everyone wants. So we've got to make sure we meet demand. Now we've added a second challenge, which is we need to reduce emissions while meeting that demand. And we'll talk about the various sectors and things like that. But let me bring in 2 more dimensions. One is scale. This is a 150-year-old industry that has achieved scales that, quite frankly, were unimaginable to me when I started back in 1987. So let's talk about scale. And let's bring in another dimension, which is we have to provide energy access to those that don't have energy. So Sridhar did a very nice job of talking about equity and making sure that people aren't left behind and things like that. Well, step one is getting access to energy. So if you don't have access to energy, the rest of this discussion is actually not even possible. And as I said, there's about 1 billion people out there that don't have access to energy, about 3 billion people out there that still don't have the types of quality of life that those of us in the developed nations enjoy. So we got a challenge, and let's get to the root cause of the challenge, and that is we have a technology gap. And Sridhar gave out some examples of ways to close the technology, but let's remember that there is no singular technology. And technologies need to meet two objectives. They need to meet demand, and they need to lower emissions. One without the other isn't going to work. So you have to keep meeting demand, and you have to lower the emissions. And you can do that through a variety of things. You can do that through efficiency steps. You can do that through fuel switching. You can do that through whatever. But as much as I said it's a technology gap, as we start thinking about policy, we actually want policy to be technology agnostic. How does that make sense? Well, you have a technology gap, but you know what the criteria for the technology needs to be. It needs to be scalable, it needs to be affordable, and it needs to lower emissions. That's the definition of the technology. So I would encourage everybody to stay away from picking winners and losers in technology and really try to come back to what engineers do very well, which is define the problem. So we often think of this as the AND equation, but there's multiple levels to AND. There's provide energy and lower emissions. There's work across the technology, policy, infrastructure interface. Those are all ANDs. Work across disciplines. Energy doesn't have a single discipline, so we're going to focus probably more on power and industry today. But every discipline of engineering, every discipline of science, every social science, economists, politicians, everything has to come together here. This is an inclusion project unlike any other. And so we need these types of discussions are super because they're constructive. Hopefully they widen the aperture of thinking. They help us align on the problem. The more aligned you are on the problem statement, the higher the probability is that you can solve it. So as we think about the hard to decarbonize sectors like industrial, that is true. That is the area where if you look at the technology gap, there's an acute gap there. We are not deploying technologies at the scale that we need to. I know we're going to get into policy and some other discussions as we go. But as we get into this discussion, let me just keep coming back to my key points here. Meeting energy demand is paramount. Lowering emissions is paramount. Working across that AND equation. Global scale. Scale has two dimensions, both magnitude and global deployment. There is no singular solution, so all of the above is going to be needed. And again, as we get into the problem statement, is the root cause here, the root thing we're really trying to solve as engineers and scientists is to close that technology gap. Bill, I really look forward to the discussion. Thank you and Ed for inviting us, and I'll pass it back to you. Thanks.
Thanks, Vijay. Really appreciate those comments. And now what we're going to do is hear from Michael Bhatia. Michael is the Chief Technology Officer of EPICS and Henry Beckman Professor in the McKenton Department of Chemical Engineering. He's a core faculty member in the Institute for Computational Engineering and Sciences at the University of Texas, Austin. His research includes the dynamics, optimization, and control of process and energy systems. Michael, thank you.
Well, thank you, Bill, and thank you everybody for being here. I want to also thank Sridhar and Vijay for introducing the problem and describing it so well. What I would like to say is focus a bit on the technology challenges that were highlighted earlier. So as Sridhar pointed out, the sources of CO2 from industry and other greenhouse gases are quite diverse. And so what we are focusing on today is the manufacturing sector, but also power generation. So if we are to choose electrification as a solution, which as Vijay pointed out, is not the only solution, these two sectors cannot be considered in isolation anymore. So as power generation is transitioning towards renewables, which are inherently variable, that's a fact that we have to acknowledge when we think of using clean power in manufacturing systems, which account for a significant portion of the US energy consumption and global energy consumption. So as we switch manufacturing to using perhaps renewable power, the proportion of energy used by manufacturing out of the total energy demand may not change, but the composition of that energy demand would shift significantly from fossil fuel towards electricity. So as electricity plays a more and more dominant proportion or role in the mix of energy sources, then the manufacturing is going to become a much larger fraction of the grid load. So in addition to focusing on technologies that convert electricity into heat or energy for process and manufacturing, we also need to boost power generation to levels that can sustain this increased amount or demand. And also we need to find ways to transmit and distribute power to users from where it is being generated. So to build on what Vijay said, we not only need to increase energy access to people, but also need to increase energy access or different energy portfolio access for industry. So we will need to find ways for manufacturing and power generation to work together. For example, when power availability is lower because of lower generation rates by renewables, then manufacturing could maybe cut back electricity demand so that residential customers are served, for example, and then when power availability is higher, then manufacturers can ramp up production to meet demand. So EPICS really is intended to work as a system of systems or a network of networks where we want to work with power generation, we want to work with manufacturers, we want to work with policymakers, we want to work with those who provide workforce development and training services, such that we come up with solutions that engage in a meaningful way the entire energy supply chain with the ultimate goal of providing these decarbonization solutions for industry at the right scale, at the right cost, and with benefits for all those engaged, including the communities around the manufacturing facilities. So Vijay also brought up a very important point of deploying solutions at scale. So what we are doing within EPICS is we work with a number of test beds in the top emitter industries, so in the chemical sector, steel, pulp and paper, food and beverage, and cement, to be able to test solutions beyond the bench. So a lot of these test beds themselves have been around for a while. They have pilot plants that have their own industrial ecosystems. So we rely on these ecosystems in order to come up with ideas, validate them, test things at the scale that would allow them to be adopted and deployed in industry at the industrial production scale very quickly. So I can talk more about examples later as we continue our discussion, but for now, I want to turn it back to you, Bill. Thank you.
Thank you, Michael. I appreciate that. And now we have Bob Litterman. Bob enjoyed a career at Goldman Sachs and is now a partner for 23 years and is now a partner at Kepos Capital, a New York-based investment firm. He serves on several boards, including as chair of the Scannon Center, co-chair of the Climate Leadership Council, and premier member of the Climate-Related Financial Risk Advisory Committee of the U.S. Treasury. Bob, thanks for being on our webinar.
Well, thank you. It's an honor really to be here. I'm an economist and I spent my career as a financial risk manager, so I'll try to bring the perspective of risk management to this discussion. My most important message here is very simple. Time itself is a scarce resource when you're managing risk. If we have enough time, we can solve almost any problem. It's when we run out of time, the risk can become a catastrophe. Given the obvious impacts of climate change this past year, the heat, the wildfires, warming oceans, sea level rise, and so on, the fingerprints of climate change are everywhere. I think we all understand that we need to be on an urgent path to net zero emissions. The question is, are we going to get there in time to protect nature and prevent a catastrophic decline in living standards for future generations? Let's hope so, but hope is not a risk management strategy. We know that burning fossil fuels increases risk. The fundamental problem is not that we don't have the technology to reduce emissions. The fundamental problem is that we don't have the financial incentives in place to change behavior. Therefore, we're not investing in low carbon technology, capital, and infrastructure at the scale we need. Bloomberg New Energy Finance estimates that last year, the world spent $1.8 trillion invested in global clean energy solutions, primarily electric transport, renewable energy, and electric grids. That is significant, and that was a 17% increase over the previous year. By far the largest share, $676 billion, according to Bloomberg, it was spent by China and almost 4% of its GDP. The US invested less than half of that, $303 billion, amounting to only 1% of our GDP. In Europe, the spending is in between, about 2.5%. Bloomberg estimates that the world needs to invest on average almost 3 times that every year between now and 2030 to be on track to reach net zero by 2050. That would require a 30% increase every year. So we're off track. Why are we off track and how do we get there? The answer is incentives. The problem is very simple. We lack appropriate incentives, and incentives are fundamental. People invest to make profits. If you want to increase investment in low carbon capital, you have to increase the expected return on investment in low carbon capital. Reducing emissions costs money. If you want to increase investments in low carbon solutions, you have to make entrepreneurs and investors expect to get paid for reducing emissions. So what is the appropriate incentive to reduce emissions? It's a quantity that economists call the social cost of carbon. Given the uncertainty about the future, no one knows what the social cost of carbon is. Economists estimate this quantity by projecting emissions, their impacts, and the damages under different scenarios, and then calculating the current discounted value of those damages. I've published work, along with others, that attempts to estimate the social cost of carbon. And while it's very uncertain, the current consensus is that this cost is about $200 per ton of carbon dioxide emitted into the atmosphere. By the way, economists often assume that the appropriate price is this median estimate of a wide distribution of estimates of the social cost of carbon. As a risk manager, I would point out that if we want a high confidence of solving this problem, then we better be prepared for a worst case scenario, which implies that we ought to price carbon somewhere near the top of that wide distribution. So where is carbon pollution actually priced? I'm afraid it's a very sad story. And it's the reason that we're not on track to decarbonize the industrial sector. It varies, but on average globally, carbon dioxide is not priced. Some places there are incentives to reduce emissions, but in many places there's subsidies to fossil fuel production and consumption. The IMF, the Monetary Fund, estimates that global subsidies to fossil fuels in 2022 were $7 trillion. There are 3 things to notice about this huge subsidy. First, it's insanely large. You have to pay attention. When New York Times wrote a story last August based on the IMF estimate, it reported the subsidy was $7 billion. That's 3 orders of magnitude too small. When I read the story that afternoon, I recognized the error and emailed the editor, and then they corrected it. Trillions, not billions. But no one else had noticed. Now, second, this subsidy comes in 2 parts. There's the explicit subsidies that are estimated at about 1.5 trillion. The Mexican government, for example, bailed out the bonds of the Mexican oil producer Pemex. That's billions of dollars of subsidy. In the Middle East, there are fixed below market prices for electricity and oil. Again, significant subsidies. But most of it comes from the implicit subsidies, not pricing the externalities created by burning fossil fuel, primarily particulate pollution and carbon dioxide emissions. These implicit subsidies are the largest part and are estimated at 5.5 trillion. The third thing to notice is that this is actually a very conservative estimate. The IMF uses a value for the social cost of carbon of less than $70 per ton. If you use the consensus estimate of about $200 per ton, the subsidy would be obviously much larger. And the US component of that subsidy, according to the IMF, was $757 billion. To use a value of $200 per ton, the US component would be well over $1 trillion. And compare that to the subsidies to clean energy embedded in the Inflation Reduction Act, the largest US government program, which is somewhere between $40 billion and $100 billion per year. In other words, less than 1/10 of the subsidy. We're trying to move toward a clean energy economy, and we have a hurricane force wind pushing us in the wrong direction. My firm has developed a measure of the marginal incentives to reduce emissions by country and over time. We include not only carbon taxes, but also gasoline taxes, subsidies of various kinds, 7 types of policies in total. It's a comprehensive measure of incentives to reduce emissions by country and over time. This comprehensive measure of global average carbon pricing has been very slowly increasing from 2008 to 2021, rising from $8 per ton to $19 per ton of carbon dioxide equivalents, led by European countries, which in 2021 all had incentives above $100 a ton. In the US, the price, driven almost entirely by gasoline taxes, was just below the global average at $18 a ton. Unfortunately, then in 2022, Russia invaded Ukraine and the Europeans began heavily subsidizing fossil fuels. Tragically, the global average price for emissions in 2022 fell to $4 per ton. It should be 50 times higher. The bottom line is we're not pricing climate risk, and this is absolutely essential. It is the fundamental problem. I'd like to quote the president of Singapore, Tharman Shanmugaratnam, who told a panel at the recent Davos World Economic Forum, quote, "There is no realistic or fair solution to the climate transition that does not involve a globally coordinated system of carbon taxes. It's a fair solution. It's the only realistic solution. Either we price climate risk or we continue on a path to make the planet unlivable. Right now, we're on the latter path. It's time to slam on the brakes." Thank you.
Thank you, Bob. And I'm going to ask everybody to sort of put their cameras back on, because we're going to go to a, I'm going to call it a panel conversation. I've noticed here in the chat that there's some questions about, is there a transcript available or is there a recording available? And as Ed said earlier, there will be a recording available. So you can share it with people. You can go back and take your notes on it. So it's all here for you, because this is a really important conversation with some really amazing thought leaders. I'd like to start the discussion perhaps thinking about Vijay, what you think the industry, the oil industry and ExxonMobil think about when they see what's working and what's not working, and where the big investments are going to be going. Because as Bob was saying a few minutes ago, we've got to put the accelerator down, but the accelerator needs more. What's your thinking about that?
Well, first off, I must say the other 3 guys, wow, those were really amazing opening comments. And I think again, the summary of the opening comments is, this is a big challenge. This is not a simple thing, and all of these dimensions need to be thought about. So let's talk about that a little bit. And I'm going to pick on a word that many of you use either explicitly or implicitly, and that is accelerate. Okay, that is where we are right now, right? So if you think about math, this is a second derivative problem, right? This is not speed, this is not velocity, this is about acceleration. And so how do you get to the acceleration? Because you don't start at the scales we're at today. Quite frankly, with all due respect to everybody, I do think there's a technology gap. How can you close that technology gap? One way to do that is with policy. We've seen that. We've seen the policies, Bob talked about the solar and the wind deployment. That was enabled by policies. And so we see things happening that are enabling technologies to be deployed. And here's the other thing we know, and this has been proven across in multiple industries, and that is, as you deploy, 2 things happen. Scale goes up, cost goes down. Now let me bring in the other thing that Bob said, which is we're out of time, or we're running out of time. Okay, well, how do you factor that in? Well, if you actually listen to what was said up until this point, it was a discussion of how to do things in series. Okay? What I would propose is we have to do things in parallel. So we've got to think about policy, technology, and Bob, we didn't mention this, but infrastructure is critical because, you know, there's a lot of movement in energy, right? Whether for this discussion, maybe we talk about high power transmission and high voltage direct current and all this stuff that has to happen for power. But for carbon capture, you can capture the CO2, then you got to move the CO2. Okay. For hydrogen, you can produce the hydrogen, but then, you know, moving hydrogen, that's not the most trivial thing to do. So all of these things have to be thought together. And unfortunately, a lot of the discussions we have are singular. So they're one at a time discussions, not integrating it across, you know, what we call integrated assessment modeling, integrating across to understand this. So what works? Let me answer your question now. So what works are policies that are technology agnostic, that encourage technology deployment. So I would say the 45s, the IRA, that's a good first step. And you're beginning to see it. There are more carbon capture projects being announced. There are more hydrogen projects being announced, including ours, which would be the largest ever clean hydrogen project when built. And it's supported by policy. Now we're also getting into lithium. Now that's not supported directly by the IRA, but guess what is? Electric vehicles. Guess what electric vehicles need? Lithium. So let's do things in parallel. Let's understand how all these integrate together and let's go. Where do I think we're not as perfect is when we have technology-centric policies or exclusionary policies, right? This isn't inclusive. This is an and problem, not an or problem. So you really want technologies, you want multiple shots on goal. So I don't think we want to pick the winning or the losing technology. And even within a sector, they call it hydrogen, where you have, I don't know, 9 different colors. I mean, there's lots of colors of hydrogen. Really, all that matters is how much CO2 is emitted when you're producing and using the hydrogen. Color doesn't matter. So we got to have the conversation around the variable that Bob and Sridhar and Michael all mentioned, right? The variable here is emissions. We need to reduce emissions. And the final thing is, in reducing emissions, and Bob talked about Europe and Bob talked about other parts of the world, if in order to reduce emissions, you have to decrease demand, that's kind of a non-starter. You've got to be able to meet demand and lower emissions. I will contend, and through this discussion, I hope we can keep talking about it. Let's focus on the trifecta of technology, policy, and infrastructure. You got 4 guys on this panel. Each of us have a specific interest, technology, policy, infrastructure, but bringing those together and working those in parallel, I think is going to be a critical next step to do the things that Bob was talking about. Thank you.
Hey, thanks, BJ. I'm going to sort of ask Sridhar if he might talk about this idea of how EPICS is going to contribute to this parallel kind of process that BJ was talking about. And admittedly, EPICS is not the whole universe of energy, but could you make a few comments about that?
Sure. So I agree with much of what BJ said. Although at some point, you know, I think as end users, there's also our behavior may have to change at some point as well if you really want to make an impact, meaning demand, right? But that being said, how will EPICS contribute to this? One thing is EPICS has to, the industries that we are our stakeholders, they're looking for cost-effective solutions. So at the end of the day, they want to be able to do this in a way where, you know, they can still produce their products and make profit for their companies, right? So what EPICS does is brings different parts of the stakeholders together to develop a solution, but also put that solution in context of techno-economics. So if you have a number of solutions, which ones might be scalable, where and when, and where might be you know, dependent on your geographic locations of what renewable, what storage, all that systems are available at your different geographic locations. When might depend on exactly what BJ said, you know, what incentives, how will they get us there? How is the hydrogen and electricity supply going to look like? And that may tell us when these technologies will be cost effective. And providing that kind of information, we believe will de-risk industrial investment, that you know that this is going to be cost effective at these places if these things happen. So we are not suggesting or propagating policy. That's not what we do as EPICS, but we provide data that others can use that may inform policy for how these incentives may roll out. I'll give it over to maybe Michael may have something to add from a technical perspective as well, what EPICS would do.
Yeah, so thank you, Sridhar. So to build on that, I think the demand needs to be met, but that doesn't mean demand is rigid. So I think we've had numerous discussions within EPICS, within the community, the industry community, where there's some, to speak in economic terms, Bob, there is elasticity to the demand, right? So that means that if there's some amount of change in energy price or energy cost that goes with an increase in demand, or vice versa, then the consumers will adapt. And the same goes for CO2 emissions, right? You have to think of I think Bob laid out the case very well as to how that will impact the behavior of users. So we are working more on the demand, the power demand elasticity side, and a lot of the work that we carry out has to do with accepting that renewable electricity will be available, but will not be available all the time. So for now, we're in a position where, for example, wind generation is curtailed in many cases quite significantly. So that means power would be available, but there's no use for it at the time when it is available. So providing industrial flexibility, so large loads that are able to absorb this power and modulate their use in a way that makes meaningful use of current and future generation capacity, I think is one of the answers. Of course, not the complete answer, not the entire answer to the issue of load. So the load may increase, but if this load is more flexible, more elastic, then it will in turn incentivize future developments in power generation. And this is why I was saying earlier, the manufacturing sector and the power generation sector, as they both transform, we envision them as being more and more intertwined. That's on one side. So that's the flexibility of demand. And then demand can go lower. So again, focusing on electricity, not as the only solution, but as really the bread and butter of what we do within EPICS. Electricity enables new ways to manufacture, new ways to think about production that, for example, offer higher quality, higher energy efficiency, higher safety, or they enable the production of materials or items that could not be made otherwise. So just to focus on the petrochemical sector, one of the things that we look at is switching high temperature reactions or reactors from heating with fossil fuel combustion to electric heating. And this will do several things. So for the audience, if you are not an expert in chemical processing, chemical reactions often happen in basically something that looks like a long pipe that's filled with catalyst, and that pipe is heated from the outside with some flames. So if we switch to, for example, radio frequency heating, we can excite radio frequency susceptors within the pipe. So we go from heating just the boundary and expecting that heat would kind of seep in, to heating the mass inside the pipe, and that will provide for much more efficient heating, more control over the way chemical reactions are done, and it will enable us to switch from what we classically think of a chemical reactor as an adiabatic system. So it's a system where heat doesn't change, but the temperature changes, to an isothermal system where we actually can control the temperature very tightly. So that in and of itself will allow us to reduce the size of the reactor by about a half and so on. So just to give a few examples where load, yes, it needs to be met, but the characteristics of that load can be changed quite drastically in a way that suits the new landscape of energy generation. So I think that a lot of thought can go into policy, but a lot of thought can also go into technology. And these technologies can help in a meaningful way the adoption of renewable energy, and also reductions in emissions that are associated with manufacturing. So I can pass it back to Vijay and Bob maybe for their thoughts on this.
Thanks, Michael. And Bob, you made the point that time is really important here in this equation. And if you're going to do things in massive parallel, processing, how do you, where there's not only an innovation gap, but there's also a funding gap, right? And, maybe can you give us some ideas about how you think we might attack that problem, or think about different ways that we can solve that problem?
Sure. Well, when you talk about a funding gap, it sounds like you're looking maybe for government funding or maybe philanthropic funding. What we need is we need private investment. And in order to get private investment, we need incentives. We need, entrepreneurs and investors who think there's an opportunity there. Now, there is obviously a role for government to create those incentives, and also to pick up on something that Vijay said, we do have to operate in parallel. And for example, we need to be building the grid that we need for the future, not the grid that we needed in the past. Right now, solar energy is really, in many places, the cheapest way of producing electricity. But, there's a huge backlog of getting connected to the grid. And that's because our federal government just has not bit the bullet and said, we've got to build the grid for the future. And, if 10 years from now, we figure out that things are much worse than we think today, and we've got to accelerate the process, it's too late. We will be 10 years down the road, and you don't replace the grid in 10 years. It takes a long time to make these kinds of investments. And so, to pick up on something else Vijay said, we have to operate in parallel. And as an economist, what I would tell you is when you put appropriate incentives in place, everyone moves in the right direction. Consumers, do the appropriate amount, which is not a lot. In fact, energy demand is certainly going to increase. You can see it with, the advent of artificial intelligence and Bitcoin and all these uses of energy. People want more energy, not less. So we're not going to solve this by cutting back on consumption. We're going to solve it by giving people the right incentives, operating in parallel, government doing what government needs to do, which is, for example, building the grid and also funding research and development. And we can solve this problem, but we have to get those incentives in place. Right now, as I say, $7 trillion of subsidies, it's pushing us in the wrong direction hugely. And so, of course, we're not making appropriate progress. So I would say the most important thing we can do is get rid of that $7 trillion of subsidies, and that'll make a huge difference.
Right.
So Vijay, just thinking about what Bob was saying there, how would you see, sort of policies getting implemented that would, make your, company more interested in making more investments and getting shareholders to, be, focused on, being able to put more money into, the energy sector?
Yeah, well, I'm going to go back to, you guys have taken a couple of my words around parallel and scale. Let me bring back the other most important word here, which is and. It's and, okay? And they're not and at 50-50, okay? They're and with a system today of 600 quadrillion BTUs a year of energy, okay? The scales are just incredibly large. What was a world scale refinery when I started back in the 80s is now an expansion, okay? Is a debottleneck. So the scale of the petrochemical industry relative to 35 years ago when I started is ridiculously large. And I want to just make one more comment before I answer your question. Listen, efficiency is actually one of the greatest sources of energy. So we talked about demand. I didn't say insatiable demand. I said you have to meet demand. And demand is defined by all sorts of things. But you want to think about efficiency, you think about your miles per gallon. Think about the lightweight, how much lighter your luggage is. All those things, air retention in your tires. So efficiency is always going to play a critical role. Let's come back to the question now. which Bob referenced and Bill, you referenced. Okay, step one, let's go back to series and then we'll do parallel. Okay, you got to meet demand. And the externalities have to be considered in making sure that demand is met. And we've just went through 4 consecutive years of one-of-a-kind externalities. So I think we got to be just a little bit thoughtful in terms of how we talk about this and say, okay, we've got to meet demand, and we've got to start deploying technology. So you asked about what Exxon is doing. So let's talk about that for just a minute, because we have $20 billion of capital pursuing low carbon technologies, carbon capture, hydrogen, biofuels, lithium, things like that. Now, that is not as much as we have in the base, but that's because the base is at scale and the emerging technologies are not. So what do you need? Well, again, come back to the IRA, because the IRA incentivizes getting these technologies on the deployment curve. What is the one thing all 4 of us are going to agree upon? And that is scale goes up, cost goes down, but you don't start at scale. You start at what I call scalable scale. And that's what the policies, I think, need to think about. Are they incentivizing deployments at scales which will allow you to get on these learning curves so that you can accelerate coming down the curve? And dare I say, if you get more aggressive and start doing things in parallel, you start skipping steps. You start skipping scale steps so that you can go faster. So there are things that we can do to accelerate, but that policy technology interface is critical, where policy has line of sight to markets, as Bob has said over and over again. Policies have to incentivize markets. Technology has to have pathway to scale. So if you're placing investments in technology and you have pathway to scale, that's a good idea. The final piece of this triangle, though, let's not forget it, because that Bob talked about it as well. When he said we don't have connections to the grid, that is neither policy nor technology. That's flat out infrastructure. Okay, so if we don't bring in infrastructure into this discussion, and my final comment before I throw it over for others to comment is, look, developing nations are starting with a clean sheet of paper. So they can start with a grid design for the 21st century, just like they did with telecommunications, just like they did with cable TV, just like they did with medicine. They're able to start where the developed nations left off. So again, defining the problem geographically, recognizing in the US it's going to be a lot of retrofit, because Michael and Sridhar both talked about the invested capital in this industry already. You want to retrofit, you want to utilize that capital as much as you want. Policies that incentivize that are good. Developing nations, they need to leapfrog. They need to think about how do you start from the beginning? How do you build CO2 infrastructure, hydrogen infrastructure at the beginning? So again, it is a very complicated problem. All 4 of us have different perspectives. Bill, the beauty of this panel is these 4 perspectives need to work in parallel, need to build off each other and be inclusionary. And I think we increase our chances exponentially of meeting the ambitions of society. Thanks.
Yeah, thank you very much for that, BJ. I'm going to turn to some of the audience questions. And, one of the things we've all noticed is the emergence of large language models and artificial intelligence. And in fact, students everywhere at ASU that I bump into are all using ChatGPT. In fact, anybody can use ChatGPT. So that's like totally cool. And all of a sudden we're saying everybody's using it. So can you guys on the panel, both from the academic perspective, the ethics perspective, the industrial perspective, and the finance perspective, just go do a round robin here quickly about where you see this all going? And maybe Sridhar, we'll start with you, and then just rock around the panel here.
Yeah, there must be so many opportunities and ways of utilizing this, but a lot of the questions that we're addressing would never be able to be solved in terms of multi-scale modeling in a traditional way, whether it's demand response, whether it's how materials respond to electric heating technologies, how you connect that to economics and markets. It will be very difficult, right? And also in terms of consumer demands. So I can imagine AI helping to answer some of those things without necessarily going to the granularity that we used to do. I'll pass it on to the next person.
Well, I can go
So
since
Bob,
I'll
or
go
BJ,
real
go
quick.
ahead.
If
Yeah.
that's okay, I'll go real quick. Sridhar, you're exactly right.
Yeah.
So what computing allows us is to accelerate. It allows you to screen. It allows you to analyze quantities of data, right? So you can optimize. So one of the biggest steps to efficiency when you're running a large refinery or a large chemical plant is process controls. The faster you can process the data, the faster you can optimize energy use. So I think that's good. I'm also excited about the ability to screen materials. You guys talked about high temperature, high pressures that are needed here. Well, if you can get membranes, if you can get active materials that can work at lower temperatures and lower pressures, that can also help decarbonize the industrial sector. And then the final thing I would tell you is that these are complex problems. And so AI is really important. But I'm going to come back to, I'm a chemical engineer, so I'm not going to go away from domain knowledge matters as well, okay? So again, doing it in parallel, letting AI do what AI can do, let big data do what big data can do, but then making sure that we have the protocols and the steps in place so that the engineers have the ability to do that final check and make sure, I mean, the safety and the we got to make sure that everything works the way it's supposed to work. So I think it's an enabler. I'm excited about it. And I think it's going to be integrated in just like what we do today was not imaginable 50 years ago. I think AI is going to open up a series of opportunities and allow us to even do further integrations.
So maybe I can comment.
Bob, what about finance? Oh, Michael, go ahead. Go ahead.
Yeah, no
Go
problem.
ahead.
So, yeah, so I was thinking AI does play a very important role in many aspects of our daily lives. And I think people got used to the idea that it can be used to answer questions, ask questions, and get answers. I would say in our field, in this particular endeavor, there is a specific subset of AI tools that are helpful, which are those that are constrained by physics. So let's not forget that mass and energy balances still have to close, right? So what goes in must come out, and this is something that we should never forget from an economic perspective, from a safety perspective, from an operational perspective. So I'd say there's a lot to be done with AI, but within the bounds of what physics allow. The other specifically, I think what will help or where AI will be very helpful is in projections. So when we start thinking about, for example, forecasting solar generation over the short term, that's a very important problem. That's where this sort of sector coupling comes in from conventional generation and solar power generation. So solar drops off very quickly in the evening, and then currently conventional peaker power plants have to take over. If we had a better understanding of how that drop off happens and have good accuracy around that, then we can far better project what to do with conventional generators, which are used to make up for that difference. And those are actually the most polluting generators that we have. So it's this type of application where we can account for a lot of factors that we can't measure or not directly measure and make good projections where AI, I think, is making an impact already.
And I would say, first of all, I agree with everything that's been said. I think AI is one of the most, optimistic things that has happened, in the last 10 years, if not longer. And, who knows what applying the, intelligence of these computers to our problems will do. Certainly, it has a very important role in a lot of these areas in terms of reducing the amount of energy required, in terms of making the grid more efficient, et cetera, et cetera. I would say that the fundamental problem is global, it's political, and I'm not sure that AI is going to be able to, help on that. Mm-hmm. And what I would say is we really need to focus on, as Tarman said, globally harmonized incentives to reduce emissions. That's what we need. And, until we get there, we're not moving in the right direction. And when we get there, I'm confident we'll move very quickly. But, right now, we've got that hurricane force wind. So how do we get rid of that? And how do we get the wind behind us rather than in our face?
That's a really good question. Ed, I see you're joining us here. You've probably got some synthesis of some of the questions from the audiences. Do you want to?
I've been trying. They've been coming in at such a rapid rate. I'm reading like a bandit to try to get to all of them. There's a lot of questions about individual technologies. Hydrogen, does that make sense or not? Why DOE is putting its finger on the scale? Why not take it off? As VJ said, that might not be that good for a lot of things that Exxon might be investing in. However, but but that aside, there's kind of an underlying question here about is this enough? Matching demand, matching supply with demand is fine if demand is stationary, but demand is on a freight train. So now we're trying to get supply to catch up with that freight train all the time. So it's like we're always running in place. Could you just comment on that and how we get off this merry-go-round onto a way that we can actually manage the economy, which is really what we have to do, so that we have supply and demand of energy in balance and not accelerating at the rate that we're continually extracting from the earth, which in the end is going to be unsustainable unless we have a place for every one of those molecules that come out of the ground to go as we plan those extractions. So maybe start with Bob, because this is kind of an economic question, I would say.
Well, look, I would say if we priced energy appropriately, then people will use the appropriate amount. And when we heavily subsidize fossil fuels, we're going to create too much pollution. So, and it'll affect things differently. I mean, yes, the price of gasoline at the pump should be much higher than it is, maybe $1, maybe $2. The price of, and we would drive less, or we would all switch to electric vehicles, and the price of, for a lot of us that fly a fair amount, that price is like half of what it should be. We're not pricing the externalities. And all I would say is if we price the externalities, we'll all be making the right decisions. And as long as we don't price the externalities, we're all making the wrong decisions. And we're not getting, we're not accelerating, we're not getting at scale, and we won't. It's an economic problem. And as an economist, the solution is very obvious, not what technology you use, not how much energy we will be using. I don't know those answers, but what I do know is that as long as we're subsidizing pollution, we're going to create too much pollution, and that's the world we live in.
Right. Bob, the pollution tax raises the price of goods, which would say disrupts the economy from where it is and sort of translates it over to maybe a different basis. What about where does that actually go? Because the economy right now is based on a cheap transportable energy source, fossil fuel, and now we start to curtail that and move to something else. What's the economy going to look like in the transition to some economic sustainability?
Yeah, I don't think it's going to be particularly disruptive.
Okay.
You give people the right incentives and they make the right answer. I mean, they make the right decisions. Now, I don't want to be Pollyannish here, but the most important thing is that we create the right expectations. And the right expectations, I mean, for investors, that carbon will be priced at some point in the future. I would ask everyone in the audience to think about what do they expect the price of carbon to be, 10 years from now or 20 years from now. And, I think sadly, most people don't think it's going to be priced. I think most people think it's never going to be priced. Well, that's a dead end. We have to create an understanding that everyone agrees with that we need to put a price on carbon. And once we do that, investors, oil companies and electric companies, everyone will say, oh, okay, that's the world we're going to be living in. These are the things I need to do, whether it's where I live, where I work, what I consume, those things all come into play. And there's a million of them. VJ said we got to work in parallel, we got to work in scale. It's and I would say yes to all of that. And the way you get that done is you put the appropriate price on carbon and you stop the $7 trillion annual subsidy to fossil fuels. And I hope we can all agree that that's the right solution.
Great. Bill or maybe VJ, a response to that? How do you see the future if there is a price on.
I think, Bob, I think we just got to make sure we don't oversimplify this problem. Okay, I agree. I think most of on this panel would agree that a price on carbon is needed. And let's make sure everybody understands. When we say carbon, we really mean carbon dioxide. Okay, not carbon. Okay, the world without carbon will be a very difficult place to live in. Okay, so let's remember that. Okay, that it is carbon dioxide, which really means this is the emissions. So let's be transparent. So we talked about the IRA. Let's use an example: $85 a ton cost of carbon (CO2) to incentivize CCS. That's good. Okay, cost of carbon for EVs, multiples higher.
Mhm.
Transparent? Not so much. So I do think we have to make sure that when we're having this discussion, we agree on the principles. And the principles that we all agree on is demand needs to be met, emissions need to come down. It isn't a singular solution. The economics, the policy, like I talked earlier, right? This is awesome because engineers and economists need to come together. And we need to really have this type of discussion where Bob is challenging us to say, well, wait a minute, I don't think this should happen. I don't think that should happen. I'm coming back saying, okay, well, if you want to get to gigaton scale, which is where we want to get to, because we're right now at million ton scale, where again, we're 3 zeros off, to use Bob's comment from earlier. Okay, well, let's look for areas where we agree, because I think, finding areas we disagree often drive the division, right? I said this is an inclusion project. And so let's make sure that there's lots of areas we agree. And I think we ought to build off of the areas we agree. And the more you do those, you'll overwhelm the areas we don't agree on, which I think are minor and I think are nuanced, quite frankly. But it comes back to those fundamentals. And I think we got to figure out pathways to scale. That's where AI, that's where modeling can really help. But getting the economics, getting the technology to work together is where we need to go. And Bob, I think you and I agree on that. I don't think we disagree.
Yeah, I don't know that we disagree on anything, BJ.
Yeah.
Well, we can all agree that it's a really hard task, and if we're really, really, really clever about it, we can all make a contribution. Sometimes it's when you think of when you think about the monumentality of 100 million barrels a day of oil moving around the world, and then there's the electricity and everything else, you just go, man, that's a huge amount of momentum. And how do we change that momentum? So what I'd like to ask each of the panelists to do is think about something that makes you feel hopeful about what you're doing. So it could be a technology in an iron and steel where we can say, well, that's just a piece of what a group of people have done, but other people may be doing something else. Maybe there's something in petchems, maybe there's something in CCS, or maybe there's something around what markets are going to do to help us price carbon. So does anybody want to volunteer to pick up the theme about what do you think? What's your hopeful thing right now that we can inspire the audience with, which is to say there are things that are happening that are kind of cool, and what's your cool project for the day, because it may change tomorrow when you find something else.
Well, Bill, I'll give you one very positive thing to focus on, and that is the growth of the renewable sector in China. They are moving very quickly toward a green economy. I wish we were moving as quickly as they are. And Europe, before the Ukraine war, had a pretty significant price on carbon. So that was also very positive. Sadly, the Ukraine war, knocked that out. And sadly, we don't have I would say, a global governance structure that yet has been up to the task. But if we can all work together and recognize the problem, it can be solved. One other thing I'll tell you that perhaps is optimistic, a couple of my colleagues and I put together a model to try and understand what the social cost of carbon is. And first of all, if you don't have catastrophic outcomes, it's not too bad. So what you're worried about is something that you think is very unlikely. It's very hard if you have optimal policy to actually lead to catastrophe, because if you have optimal policy, if you price things appropriately, you reduce emissions very quickly, and you solve the problem. The unfortunate thing, again, when you think about this as a risk management problem, is that we don't know what the future is, so we don't really know what the optimal policy is. And, you know, we're guessing, we're operating in a fog, and things could be much worse than we expect. And in any case, we haven't really gotten started because we haven't started pricing carbon yet, carbon dioxide.
All right, Bob, I can see that there's some positives and some negatives there. I'm going to ask you one last question, though, about this. How should we be feeling about, you know, the work that's your work that's going on in Treasury and other people's work on getting carbon markets? You know, we've seen a number of articles coming out about agricultural carbon, and you know, people are like going, oh, you know, maybe that's not so good. So can you give us kind of a sense of where that's going?
Well, I can be pretty optimistic about that. No one knows, but the Europeans are now moving forward with a carbon border adjustment mechanism. They're negotiating with the US about such a mechanism with respect to steel and aluminum. And, you know, I'm personally optimistic that if the US and Europe basically create prices on carbon with border adjustments, that China would go along. And then very quickly, the rest of the world would go along as well. It's certainly in all of our interests to work together. So in the US, we have not, you know, our political system is in a bit of turmoil right now, so it's hard to be optimistic about that. But there are both Republicans and Democrats who are recognizing that we need to measure the carbon content of goods. We eventually need to put incentives there to reduce that. And so I'm hopeful next year, you know, the Trump tax cuts roll off, and there's going to be a desperate need to raise, you know, revenue, or else, you know, there's going to be a significant tax increase that I don't think anyone wants. And so there's going to be a negotiation on fiscal policy. And, you know, the obvious answer is put a price on carbon and raise something like $2 trillion of revenue for the government over the next, you know, 10 years. So there are solutions out there. They're being discussed in Congress behind the scenes. And, you know, I pray that we get there.
Okay,
Bill,
so there's a chance that policymakers may be in the same life draft and may realize that there's an opportunity to collaborate. Ed, I
Bill,
cut you off, sorry.
there's several questions here about the technologies that Michael and Sridhar are seeing that they think are most promising. There's a mention of hydrogen,
Yes.
although we don't know that you're working in hydrogen, but some of the other heavy industries coming up. What do you see that's optimistic from both of your experiences? Michael, maybe you can go first because you look like you're thinking about it.
I think that for those predicting doom and gloom, you know, we switched from steam locomotives to electric trains quite successfully. It took a while, but the technology developments have been amazing, and clearly nobody wants to go back. We are far away from where we were 20 years ago as far as electric cars go. Right, so it's no longer kind of a frumpy base model that is stuffed with batteries. It's now a very desirable product, and accessible product in many cases, with or without the tax incentives. So I think there's reasons to be optimistic about having the ability to create technology that is desirable to the market, advanced from a technological point of view, and non-polluting. So granted, these don't touch necessarily the sectors that we are talking about today, so manufacturing, but I still think that we have examples and we have stories that we can learn from. So in terms of technological development, there's a lot of excitement around, for example, the use of hydrogen for sure. That's not necessarily our purview immediately, but for example, hydrogen blending and natural gas pipelines is something that can be used to reduce emissions to combustion natural gas in different places. Use of hydrogen as a fuel directly, certainly something worth considering, although there's some issues with that related to safety, related to the economics. But hydrogen is not really the only solution. I would say we need to take a holistic perspective where a lot of the energy can come from renewables. We also need to consider nuclear. So recently, one of the members of EPICS has reported that they are building a plant powered by a small modular nuclear reactor. So I think there's a lot of things to be optimistic about. Our role is to really bring it all together, have a system-wide perspective, and understand which technology can play a role where, and how it can be beneficial, and optimize its engagement towards the goal of reducing carbon emissions at the industry level.
Sridhar, what about you? What do you see that's optimistic so far? And Epic C is new, but you have a much broader background than that. And you might also maybe spend a minute or two just explaining about Epic C, what it is, because I don't think we actually went into that.
Sure. So I think I briefly described it in the beginning. EPICS is a public-private partnership. So we have around 110 or so companies now, all the way from utilities to manufacturers to companies that provide technologies for electrification. We also have unions, national labs, and looking to kind of solve the problem together. So maybe I'll use that as a context. What I find is interesting and optimistic is I see kind of solutions coming together which are across vertical supply chains. So it's not a single factory doing something, but they're trying to work with the utility that would ultimately make more money by selling more electricity as well, right? As well as their end user or end producer, or OEM or tier one that might be able to brand a product differently to kind of come up with economic solutions that may not even need incentives. I think Bill is right, and there will be incentives needed, but to depend on it as little as possible. I would put examples such as, the two, just my own field. In the end, all I know is about blacksmithing. The two largest H2 green steel projects are in north of Sweden, and the way they work is they're kind of conglomerations between utilities, steel makers, and also uptakers from the automotive industry that have come together to say, we're going to brand this. We may charge slightly more for this as a branded material. We're going to do these incentives so that you get the electric power, and that will incentivize the manufacturer to actually produce something. So those types of kind of vertical integrations, I think, are a new way of working that would help this kind of solutions to actually be more economical for everyone in the end. On the area of hydrogen, I think it has its place in certain places, but I don't think it's one solution for everywhere all the time. Hydrogen, or if I take the case of hydrogen-based iron making, it requires enormous amounts of electric power, about 20 terawatt hours per million tons of steel. And if you count the fact that we produce about 2 billion tons of steel in the world, I'm going to get my maths wrong, but I get it to be about 40,000 terawatt hours of power per year. All of the US consumes about 5,000. It's not reasonable to electrify all the hydrogen to make that. There has to be a number of solutions that might be suitable depending on your geographic locations, depending on your other raw materials. There are different decarbonization pathways, and hydrogen is one of them. It's not scalable across the entire globe. That's my opinion.
Good. So Vijay, the oil and gas industry is a huge industry. It's got the capacity to do things at scale. What's exciting you about what you see?
All right, so I'm the R&D guy. I'm the technology guy. I'm always the optimist. Okay, and let me start with a real simple thought experiment here. Okay, what we're doing today, like in 1987, if somebody would have given me a sheet of paper and said, "Imagine energy in 2024," okay. I don't even know what ChatGPT would have said in 1987, but I don't think it would have said what we're doing today. Okay, and that's all technology. The fact that the U.S. is the largest exporter of oil and gas, really, that's all technology. The fact that we now have 8 billion people on this planet, 7 of which do have access to affordable and scalable energy, that's all technology. So optimism to me is always centered around technology. And the optimism to me is we're seeing technology at work. And the policies are driving the technologies to work. We saw it with solar and wind. Now we're beginning to see it with hydrogen. I agree, hydrogen, nothing is a one size fits all. Hydrogen provides heat. When you burn hydrogen, you don't make CO2. So depending on how you make the hydrogen, if that's why the IRA is really good, because it's based on carbon intensity or CO2 intensity of the hydrogen. It doesn't care what color you are. It just says, give me a low CO2 intensity. Okay. You want to really do international cooperation, agree on CO2 intensity. Okay. Because you get everybody on the same CO2 intensity. Systems and measurements need to be put in place. So I'm optimistic, because when people get together and unleash the force of technology, man's an amazing species, right? We have solved the unsolvable. And policy can kickstart it. Totally agree. Policy needs to kickstart it. Markets need to take over. Infrastructure. And I think we have a lot of students on this call. Okay. We need that excitement. We need the Arizona States. We need the universities. We need that collaboration. We need the best minds working on this problem, because it is an interdisciplinary problem unlike any other. And the optimism is around the more we get aligned on the problem statement: increased demand, increased supply, lower emissions, get the technology focused on that, get everybody rowing in the same direction. I think we have a higher probability of solving it. But look, we're deploying technologies today that just weren't being deployed 10 years ago. And as we get on these deployment curves, to Sridhar's point, I don't know what the winners are, but I know we have more shots on goal today than we did 10 years ago, and I think we'll have more shots on goal in the future, and I think that's what we need to do.
That's a great way of how we can think about what's hopeful. And I just want to go back and pick up a couple of thematic pieces. One is that we're working differently. Sridhar, you pointed out that these industries are collaborating with partners in the supply chain to actually do things differently. And I'm sure that we're seeing that in each one of the industries that are represented on this call, whether it's in oil and gas or steel, or whether it's in cement or even in finance. So Ed, I think we're kind of at the point now where we probably need to ask people to, leave us with their final thoughts. Does that sound right to you?
I think that's great. And Bill, I want to include you on that. And maybe we can go in reverse order of the speakers, starting with Bob and then going back up. And then Bill, I'd love to hear your thoughts in the end as well.
Well, I don't have much more to say. I'm not a technologist. I've said what my point about prices, but let me just say again, the most important thing is time is not on our side. This is an urgent problem. We should have addressed it 30 years ago. And we're really running out of time. The fingerprints of climate change are everywhere, and they're accelerating, and it's a scale problem. It's not going to be easy to solve. So we need to get started immediately. That's what I'll end on.
Great. Michael? Then Vijay, and then
urgency is certainly clear here, and we don't know how much time we have, but certainly it's something that we need to do quickly, and decarbonization should be a global priority, and more work at the global level is certainly helpful. I think here there's an opportunity for the U.S. to lead the way in terms of developing technology and also exporting it and deploying it. So this could become an actually very desirable product outside of the country beyond it being useful and desirable here. And one last thing is we should not forget our communities here. So certainly those who have borne the brunt of pollution could bear to benefit from switching to less polluting technologies.
Great. Vijay?
Well, first off, thank you for inviting us to this. This has been a super hour and a half, and hopefully folks out there have gained some perspective on this. Word of the day, obviously, scale. The second word of the day, technology. And the third word of the day is collaboration. So the more we can bring in different perspectives, the more we can integrate with students, the more we can integrate across the different social classes, to Michael's point. These all have to be thought about. This is a challenge unlike any other. That's why we're here. That's why humans are here, because we take on these challenges and we solve them. And I think we solve them because of the way we go about attacking the problem. So again, let's make sure we understand the challenge, work together constructively, inclusively, and drive towards the solutions. And I'm optimistic we can get there. It's a matter of getting on the road. And once we're on the road, just let the powers of scale and force multipliers take over. But let's get to work.
Sridhar, some final thoughts?
I agree with everything Vijay, Bob, and Michael said on technology, the policy, things like that. The only, I guess, final thought I would give is sometimes we always think about policy driving deployment. Sometimes it's the other way around. You know, once you invent a disruptive technology, there are cases where that drives policy because it can no longer be uninvented, right? So whether you like it or not, you know, the horizontal fracking drill essentially changed our energy policy once it was invented. And that changed, as Vijay said, all what we are able to do today. So like that, transformative or disruptive technologies or inventions can also change the rules of the game.
Okay, Bill, bring us home here.
All right, Ed, you're not going to let me get away with this. This has just been an amazing panel, and all of you are friends of mine, and I so appreciate you guys coming to, I'm going to say, take the issues on head on, have a little bit of agreement and disagreement where it's appropriate. And I think what we're starting to do is identify that these working models of how we collaborate and how we actually then, seed innovation and get people thinking are really important. It's a privilege for me to be working inside of ASU, where I get a chance to see students who are at the leading edge of thinking about, well, what can I do and how can I do it? And I will just say that that if we understand how we need to collaborate, then we can use those tools to find better ways of cooperating, and hopefully that will lead us to better solutions. And finally, we had that little discussion about AI. What I hadn't quite appreciated is what AI has done is it's created ways of seeing the world differently than we as humans see that. And so like in chess, there's a lot of way machines play chess that we wouldn't play chess. So that's one way that you can win. And so when you think about the possibilities of what we can do with that information and how we can apply it in a coordinated, disciplined fashion, then there is a possibility that we can actually get this trajectory right. So I'd just like to leave on the, the students and young people are going to be our future. We're here to basically lay out some of the issues, and we're hoping that you'll all be able to join us at, for the salon that had issued this invitation for when we started this.
Great, thank you for bringing that up, Bill. And that's you summed that up well, and it's a good place. It's really a good place to end. One point that I would make is if you take a look at Fifth Avenue, pictures of Fifth Avenue in New York in 1900, what you see is horse-drawn carts. If you look at 2005, you see a couple of cars. When you look at it in 2010, 2012, you just see cars and no horses. Transformation can come very, very quickly. I think we've got an enormous problem here, not to underplay it and say that this is easy. It hasn't been, but I think once all the pieces do get together, and hopefully before we do really run off a cliff, society has an amazing way to scale its speed when the pieces are moving, when the pieces are all aligned in moving direction. So I'd say that is the most optimistic thing I can say here. I apologize to those whose questions we didn't get answered. There were just too many of them. We tried to summarize them. And we saw comments of people that are supporting carbon taxes, others that are saying, I don't want to see prices go up. So this is not a closed issue, but I think having these kinds of discussions are just really so important to move the ball forward, to really get to that solution so that we can look in the rearview mirror and say, we have fixed this and we're on to a sustainable future. So Bill, it's a pleasure to work with you. Bob, always great to have you on. I'd love to have you on all of our sessions. Vijay, I really appreciate your straightforwardness on Exxon and other things. I mean, there's questions about Exxon, what it did, what it didn't do, and what it's doing now is what's really important. And Michael and Vijay, congratulations on the Epic Sea adventure, which is over, I think, 10 or 12 years. So we expect to see great things coming out of that collaboration. So please come to the sign up for the salon, especially if you have something to deliver. We're not talking about an educational process. We want to talk about more collaboration and more contribution. So with that, Let me end the session. Thank you to the panel that stayed. Thank you to the audience that stayed with us right to the end. And thank you to the panel for your just amazing experience and insights that you brought to everyone today.
Thank you.
Thank you.
Thanks.